For the next one.
All right. What does 5 say, Michaela?
It says a 2,000 kilogram truck moving slowly in a parking lot at 5 meters per second hits a 500 kilogram car initially at rest. The bumpers of the truck and the car allow the car to bounce off the truck. During the collision, the truck slows down to a speed of 3 meters per second. What is the speed of the car after the collision?
All right, so the truck's moving, the car's stationary, it hits it, the truck slows down, the car speeds up. Is this an accurate depiction of what it says here?
Yes.
All right, so let's get some colors on here then. Feeling purple for the truck today. All right, so our truck is purple. All right, and so what's the mass of the truck?
2,000 kilograms.
And what's the velocity?
5 meters per second.
Okay, afterwards, still the same mass,
Yes.
About 3 meters per second.
and it slows down to 3 meters per second. So would you say that it lost some momentum?
Yes.
It did, right? Where'd it go?
Into the smaller car.
Yeah, it went into the car. Like, that's the cool thing about momentum, is the fact that the total amount stays the same. So if the truck lost some, the car had to gain it. It's my favorite thing. All right, I feel like the car could be green. Car's green. So what's the car's mass? 1,000?
E.
Is that right?
No, 500.
Oh, lies. And we don't know its speed after. In fact, that's eventually what they want to know. True?
Yes.
All right. So when I put the masses on here to start, okay, you can see that this is 2,000 long, and if this, because it's 2,000 kilograms, and if the car is only 500, how many times longer is the purple one than the green one? 4 times longer. Is that cool? So I'm cognizant and I'm aware of the fact that I'm trying to represent by scale. And it's going at 5 meters per second. Now, I don't know how long 5 is supposed to be, but I'm just going to try to make it relative to anything else I draw on here. So if later on I have to draw a 3, I know the 3 is going to be shorter than the 5. Okay? In fact, probably 3/5 as long. Come over here, represent the masses again. Okay. I like it. So, what is the, how fast is the truck moving? 5?
When at
So what is the total area here then? 10,000? So if the total area on the left side is 10,000, what does the total area on the right side have to be?
10,000.
Got to be 10,000 also. But how much do I have? Yeah, I only have 6,000. Which means how much am I missing? 4,000. Where is it?
In the car.
It's in the car. I love this. Oh my gosh. So if it's in the car,
It has to be 2 meters.
um,
That's a lot. Wait, so how does it increase so much though? If we started at 5 meters per second? Like how would it accelerate the car that much?
because the car's mass is so much less.
Okay.
So what does the area have to be? You said 4,000? So what does the speed have to be then? If the area is 4,000 and the height is only 500, what does the speed have to be? 8. Because 500 times 8 is 4,000. So that actually answers our question. What is the speed of the car after? And it's 8 meters per second. And McKenna's question is a great one. She's like, but wait, like if I only lost 2 meters per second on the truck, how is the car going 8 meters per second? Well, the answer is that the car's mass is so much less. And because the car's mass is so much less, its speed can be so much more. All right, let's do the energies while we're here. Okay. Kinetic energy is 1/2 mv squared. The mass is 2,000. Speed is 5 squared. 1/2 of 2,000 is 1,000. 5 squared is 25, so my total energy is 25,000. Is that cool?
Yeah.
All right, let's do it for the right side now. 1/2 the mass is 2,000. 3 squared. 1/2 of 2,000 is 1,000. 3 squared is 9, so 9,000. And what about for the car? Car's moving now, so it's going to have some kinetic energy. What's 8 squared? 64. 1/2 of 64 is
32.
32. And 32 times 500,
16,000.
16,000. Now, what's cool about this is in this problem in particular, one thing that's nice about it is because the bumpers hit, you actually don't end up losing any energy. You start with 25,000, you end up with 9,000 and 16,000, which is 25,000. All right. How's that seem? Cool?